Hi, I want to talk about prime factorization so that we can get ready to reduce fractions. So what is a prime number? A prime number is only divisible by itself and 1. So 2 is prime, 3, 5, 7, 11, 13, 17, da 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 da. There are millions of primes. Note that 1 is not prime. That's not a big deal, but if you want to settle any arguments, 1 is not prime. Just because. What else is not prime? Anything that's divisible by another number. 4 is not prime because 2 times 2 is 4. 9 is not prime. 15 is not prime. 24 is not prime. 30 is not prime. And 45 is not prime. Okay, these are all called composite numbers, but I don't care if you know that word either. They're not prime. So let's go back to 24, 30, and 45 though, because I said 3 times 8 is 24, but that 8's not prime. So let's see if we can divide that again. 2 times 4 is 8. Oh, but 4 is not prime either, so let's do that again. Okay. Now these are all prime. 3 times 2 times 2 times 2. In 30, it's true that 5 times 6 is 30, but 6 is not prime, so let's do it again. Now these are all prime. 5 times 2 times 3. And 5 times 9 is 45, but 9 is not prime, so we'll do it again. 3 times 3. Now these are all prime. Now we usually write these in order from smallest to largest, but when you're doing these little trees or scratch work, just get it all down. It doesn't matter the order. So prime factorization. A factor is a number that divides it. We're looking for all of the prime factors. Sometimes prime factors appear more than once, like in 24 and 45 above. So we have 2 times 2 times 2 times 3 is 24, and 3 times 3 times 5 is 45. Okay? Prime factorization, practice. We just have to practice, practice, practice. If you don't know your times table, this is a little bit difficult and challenging and annoying, but it gets better with practice. So when you're doing prime factorization, you can start with any two numbers that you know work. Whatever number you think is easiest to divide by, do that one. Whatever order you start, you'll get the same answer. If you can't think of any number that divides it, then start small. If it's even, we can use 2. We can use 3. If it ends with 0 or 5, we can use 5. Okay, just start with anything that you know works. 55, that one's easy. We practically get that for free. What about 72? I like 72. I happen to know that it's 8 times 9. But 8 and 9 are not prime. So let's do it again. 8 is 2 times 4. 4 is not prime, so let's do it again. 2 times 2 is 4. And 3 times 3 is 9. Now all of these are prime. 72 equals 2 times 2 times 2 times 3 times 3. Oops, sorry 36. I'm getting in the way there. 36, I like to do 6 times 6 because that's how I remember that one. But 6 is not prime, so we have to do each of these again. 2 times 3 and 2 times 3. How about back up to the top? 63. 63 is 7 times 9. What about that 9? Not prime, so we have to do it again. 3 times 3. 63 equals 3 times 3 times 7. How about 60? Well, 6 and 10 is easy. Let's start there. I like to do the easy ones first. 2 times 3 is 6. And 2 times 5 is 10. 34, I don't know what times what equals 34, but I know that it's even, so I'm going to start with 2. And what do you know? 2 times 17 equals 34. Those are both prime, so we're done. Now this is going to come in handy when we reduce fractions, so please just practice and be patient and practice and be patient. Thank you.